All right, so here's the setup. I got a piece of felt here, and I drew a circle on it about, 10 centimeters in radius. I'm going to put a billiard ball right there in the center, and I'm going to put a quarter right here on top of the billiard ball, okay? The goal is, can I hit that ball with this ball and get the quarter to land outside the circle? So, a couple of rules. I have to start this ball outside of the circle and roll it in. Also, I need to consistently get the quarter outside of the 10 centimeter circle. I need to find a method where I can consistently do that. If you have this kind of materials at home, go ahead and give it a shot. Otherwise, we'll do it in class. Here's a couple of my tries. Okay, so how does all this stuff work? The billiard ball, the reason the quarter didn't move is because we didn't put a force on it, right? Nothing moved the quarter. And it's really difficult to make something move if you don't put a force on it. The first guy to really think about this was a guy by the name of Isaac Newton. Isaac Newton was alive in the late 1500s, early 1600s. He came right after Galileo. I think he may have been born the day Galileo died. So Newton, of course, is famous for lots of different things. He has 3 laws of motion and 1 law of gravity. And today, I want to focus on his first law of motion. Newton's first law of motion states this. It states that that ball will not move until I move it. That's it. That's the first law of motion. That an object at rest, that's how Newton would say it, will remain at rest, stay right there, unless acted upon by an outside force. Meaning, this ball will not move forever until I move it. Wow, mind-blowing. This guy was a genius. Newton was so smart that he actually invented calculus. Like, he didn't have math to describe some of the things he was looking at in the sky. He actually invented calculus to do it. That's how smart a guy he was. This was his first law. That will not move until I move it. Wow. Now, there's actually a second part of it. This says this ball will continue to move forever until it hits something. This ball will continue to move in a straight line forever until something affects it. Now, granted, I know in here there's some air resistance and some friction, and it's going to hit the sink or whatever it's going to hit. But if it were moving in space with no other forces acting on it, it will continue to move forever until a force acts on it. So Newton's first law is actually stated like this. An object at rest will remain at rest. An object in motion will remain in motion unless acted upon by an outside force. This is Newton's first law. It's pretty straightforward. I can't believe no one thought of it before the 1600s, but whatever. I wasn't around back then. Let's take a look at some examples of this in action. Okay, here I got a weaver's loom with a Erlenmeyer flask underneath it. On top I put a stopper. I want to show you how I can, my kung fu here, and how I can get this thing to work. And let's see if you can figure out the physics behind it. Are you ready? Okay, you got to really concentrate on this. Ha! Yeah! Did you see that? Thing fell right in there. So let me tell you a story. So here I am. I'm 16 years old, right? And I just got my license. It's Friday night. It's after a football game, okay? Now in Monticello, where I'm from, we had something we did a little weird. So we did something that, kids a lot of times would do what we called cruising the loop. Okay, now this might seem odd with gas prices the way they are and the way people want to save the planet, but back then this is how this worked. So you would get in your car and you would go down Main Street really, really slow, and you'd wave at everybody that you see, right? And then you get to Main Street, and you turn down Highway 151, and you would cruise down Highway 151 until you got to Happy Joe's. And when you get to Happy Joe's, you go in one side of Happy Joe's, around Happy Joe's, and then you come out back on 151. You cruise down 151 for a little while until you get to this Main Street again. There's a stoplight there. And you take a left, and you go down Main Street until you get to the bank. And when you get to the bank, you go in one side of the bank, out the other side of the bank, and now you're back on Main Street, and you repeat. We called this cruising the loop, and everybody did it. Literally, like after a football game, you couldn't get onto Main Street or 151 onto those highways because just there were line-to-line cars with high school kids. And I got to thinking, like, how stupid this was. But really, back then, we didn't have cell phones. So, like, if I wanted to find my friends after school, I couldn't just call them or text them or send them a snap. We didn't have any of that stuff. You know where I would find them? I'd find them on the loop. All you had to do was get in your car. And within like 2.5 minutes, you would see them on the road. You'd flag them down, and every kind of group of friends would have a place they'd stop. And then you could, like, hang out. So, back to the story. So here I am. I'm on the loop, and I'm coming down Main Street, right? And I get to the stop sign, and I turn, and I'm going down. I feel like you guys aren't getting this. Let me see if I can help you. Okay, let me see if I can't visualize this for you, okay? Let's make a little model of our situation. Playing the part of me will be Brenda. Brenda is Dollar Store Barbie. My wife's dog ate her hands, so I stole her from my daughter, okay? So there's Brenda, that's me. And here I am coming down the street, okay? So here I'm coming down Main Street right here. I get to Highway 151, there's a stop sign, or stoplight. And I turn right on red, it's kind of rainy, and I'm moving down Highway 151. Now, there's a Hardee's up over here, so I'm turned this way, driving down, everything's cool. What I don't see is the car turning into Hardee's. So there's a car here, and it's turning into Hardee's. It's like waiting to turn in the turning lane. So I come out here, I'm 16 years old in my dad's Blazer, and this is what happens. I want you to watch closely. Okay, what happened? Can you explain what happened to Brenda using Newton's first law? Brenda is an object in motion. She remains in motion until something stops her. Now, the car was stopped by the car in front of me, but I, luckily, was stopped by my seatbelt. That's why we wear seatbelts, because if I didn't have a seatbelt, something would eventually stop me. It would be the steering wheel or the dashboard or the windshield or the street, the tree outside. Something would have eventually stopped me. Because I am an object in motion, I remain in motion until acted upon by an outside force. All right, so that was my first accident, okay? I've actually only been in 2, so I'm going to tell you the second story right now, all right? So here I am. I think I'm a senior, right? And we had a dance, and I can't recall. I think it was Sadie. We called it Sadie Hawkins. I think you guys used to call it Turnabout. I don't know. There was a dance, right? And I had a date. I think you guys still do that. But so I had a date. And in Monticello, you couldn't take a date out, right? Because there's only 2 places to eat, Hardee's and Happy Joe's. And so that was a no-go. So we had always went to Cedar Rapids. Cedar Rapids is about a half hour away. So we run up to Cedar Rapids, and here I am. I'm in Marion, okay? And I'm in my mom's Chevy Lumina. And I'm sitting at this stoplight, right? And I'm actually, if you've been to Marion, you get the little downtown, you go down this big hill, and then there's a stoplight there before you turn and go by McDonald's and then up in by the new Best Buys and stuff. Anyway, I'm sitting at this stoplight, right down the bottom of this hill. And everything's going fine. I feel like these guys aren't getting this. Let me see if I can help you. So I feel like you're not visualizing this. Let's take a look at how this situation works. So here I am. I'm sitting at a stop sign. The part of me will be played by Beachbody Ken here. He's without a shirt. I had a shirt on at the time. But things are going fine. The date's okay. We're in the car. Everything seems to be all right. We're chilling at this stoplight in downtown Marion. Now, I'm just sitting there, and this car comes down the hill, okay? And what's weird is there was an accident over here in this lane. So this person was actually looking over here, and they didn't see me sitting at the stoplight. Now, I can't exactly complain because this happened to me like a year and a half earlier, but whatever. So here's what happens. So he comes down. He's actually driving a Vista Cruiser, like legitimately like from that 70s show, like one of those green things with the side paneling. It comes down and they hit me from behind. Now I want you to pay close attention to what happens to Ken. Don't pay as much attention to Barbie. Here we go. Jeez. What happened? What happened there? Can you explain this based on Newton's first law? Ken is an object at rest, right? I was at rest sitting in my car. Now, when the car beneath me starts to move, what actually attaches me to the car? Well, it's my seat, right? The seat pushes on me. Now, as the seat pushes me forward suddenly, your head weighs about 10 or 11 pounds, right? It's pretty heavy. And it's attached to your body by a very thin ligament called a neck. And so your head is actually an object at rest. And as the car pushes you forward, your head remains at rest unless acted upon by an outside force. So in this case, it remains at rest until my neck can pull it forward. What do we call this? Well, we call it whiplash, right? And it has to do with Newton's first law. An object at rest remains at rest unless acted upon by an outside force. Newton's first law is often called the law of inertia. Inertia is a vocabulary word I want you guys definitely to know. Inertia is an object's tendency to stay at rest or to move in motion. Sounds a lot like the first law. I got a couple of examples here of objects that have inertia. In fact, all objects have inertia. But which one of these objects, the bouncy ball or the ping pong ball, has more inertia? Which one has more of a tendency to stay at rest? Well, we can find that out by just putting a force on both of these balls and seeing which one moves first, right? If I blow on both of these, obviously the ping pong ball has less inertia. It has less of a tendency to stay at rest. It's easier to move and easier to stop. So essentially, inertia has to do with the object's mass. How do you guys define mass? You talked about it in chemistry. We talk about how massive people are and how massive things are, but what really is it? Well, in chemistry, they called it the amount of matter in an object. I always called it stuff, the amount of stuff that you have. The more stuff you have, the more mass you have. But in reality, mass is a measurement of an object's inertia. That's the technical definition. It's a measurement of inertia. It's measured in kilograms. The more kilograms you have, the more inertia, the harder it is to get the thing moving, the harder it is to stop the object. So mass is defined as the measurement of an object's inertia. But what about weight? We often interchange mass and weight. Mass is how much stuff you have. Weight is how much the force of gravity pulls on you. I want you to think about this. How do I gain mass? How do I actually get more massive? Well, for me, I eat Texas Roadhouse. Oh my gosh, the rolls, really? They're like 300 calories a piece. I don't care. I'll eat a dozen. And I'll go home and I will have definitely gained mass. I'm a much bigger guy after eating a dozen of those Texas Roadhouse rolls. That's how I do it. How do you gain weight? Well, actually, you kind of do the same thing, right? If I eat those Texas Roadhouse rolls, I also gain weight. So what is the difference between mass and weight? How do you lose mass? How would you lose mass? Well, exercise. Don't eat Texas Roadhouse. Cut off a limb, right? These are ways to lose mass, right? I have less stuff if I work it off, or I don't eat as much and let my body work it off, or I cut off a part of myself. That's a way to lose mass, right? Let me tell you the world's best weight loss program, okay? The world's best weight loss program. Go to the moon. You go to the moon, you weigh 1/6 of what you weigh when you're on Earth. Now, you still have the same amount of mass, but the pull of gravity, the force of gravity pulling you down, is less. Weight is the force of gravity on an object. It's a force. It's actually measured in something called newtons, named after Sir Isaac. We're going to learn more about this in the next couple of days.